All right, let's jump straight in. We're doing a deep dive today into database replication, specifically the leader-based model, sometimes kind of master-slave. If you're like me, maybe prepping for senior software engineer interviews, this stuff is, well, it's absolutely crucial, foundational for distributed systems.
Exactly. When you're building systems that need to handle, serious traffic and keep data consistent across multiple machines, leader-based replication is it's a go-to strategy. The core challenge it really tackles is making sure all your data copies are, well, up to date, especially when you've got reads and writes happening all the time.
Okay, so keeping multiple database copies in sync. Let's break down the main bits. We've got the leader replica. That's where the action happens. Yeah.
That's it. The leader, you might also hear it called the master or primary, is the single point of entry for anything that changes the data. All the write queries, sometimes even read-write queries, they go straight to the leader. And then you have the follower replicas.
Right. The slaves, secondaries, read replicas, hot standbys. Lots of names.
Yeah, exactly. Their job is basically to keep synchronized copies of the data they get from the leader.
So the followers are mainly there to handle the read-only stuff, to like spread the load.
Precisely. Imagine a user, let's say user 1234, updates their profile picture, that write request. It hits the leader.
Okay.
The leader updates his own database, sure, but it also creates a really detailed record of that change. We're talking about, which table, the specific row via its primary key, what column changed, the old value, the new value, even a transaction ID to keep things ordered. It's like a super precise log.
Ah, a really detailed change log. Got it.
And this log, these recorded changes, they get streamed out to all the follower replicas. It's often called a replication stream or change stream.
Okay.
So now if another user, say user 2345, wants to view user 12334's profile, that read query can go to a follower. And because that follower has gotten and applied the update from the leader via that stream.
They see the new profile picture.
Right, exactly. User 2345 sees the correct up-to-date info.
Okay, this makes sense. All writes hit the leader, keeping things consistent there, and then the changes flow out to the followers, which handle reads. Better performance overall. For interview prep, like understanding that separation seems key.
Absolutely. And this isn't just, theory. You find leader-based replication everywhere. The big relational databases, PostgreSQL, MySQL, Oracle Data Guard, SQL servers always in availability groups. But also in NoSQL like MongoDB, RethinkDB, Espresso, even things like Kafka and RabbitMQ, these message brokers use similar principles. Network file systems, too. It's really foundational stuff.
So leaders pushing out changes, but how does it know the followers actually got them? That's where sync versus async comes in, right? It feels like a classic interview trap.
You're spot on. Synchronization is all about, well, does the leader wait for confirmation from followers before telling the client the write is done? This is where you see that direct trade-off between consistency and write latency.
Okay, let's hit synchronous first. My take is this is about making sure at least one follower has the data before the leader says, okay, done. Prioritizing safety, kind of?
Exactly. In synchronous replication, picture a special synchronous follower, follower A. When user 1234 updates their profile, the leader processes it, then waits. It absolutely will not confirm the write back to the user until it gets a clear, yep, got it, and applied it signal back from follower A.
So the write isn't really done until it's on at least two machines, the leader and that sync follower. Sounds really good for not losing data if the leader crashes.
It gives you strong consistency, yeah, and it's great for durability. If the leader suddenly fails, you're pretty confident that the latest write is safe on that synchronous follower. But there's a big downside.
I can see it. Latency, right. And what if that sync follower has a problem, like network issues, or it just crashes?
Yeah.
The leader can't get confirmation.
Exactly.
And if the leader can't get confirmation, it can't tell the user the write worked. So writes just stop. The whole system could grind to a halt.
Precisely. That increased latency for every single write and the risk of completely blocking writes if the synchronous follower is unavailable. Those are the major drawbacks. It impacts availability potentially quite badly.
Okay, yeah. That's a serious trade-off. So what about asynchronous then?
Asynchronous is more fire and forget, like you said earlier.
Yeah.
The leader sends the update out to the followers, but it doesn't wait around. It immediately tells user 1234, yep, your write is successful.
So the user gets a much quicker response, and the leader can just crack on with the next request, doesn't get blocked waiting for slow followers. Sounds way better for write speed.
It is. Much lower latency for writes is a huge plus. The leader stays responsive even if followers are lagging a bit or having temporary network hiccups. But The trade-off is weaker consistency, meaning if the leader fails after telling the user the write was successful, but before that change actually made it to all the asynchronous followers, you could lose that write.
Oof. Okay, so the data might just vanish.
Potentially, yes. The durability isn't guaranteed the instant the user gets the confirmation. I actually saw this happen once at a previous place. We had async replication, leader died suddenly, and yeah, we lost a small bit of recent data. It really drives home why you need to understand these trade-offs for your specific application.
Wow. Okay, so it's a real balancing act. Consistency versus availability and performance. For interviewing, being able to talk through why you'd pick one over the other, that sounds crucial.
Absolutely. Which brings us to a really common approach, semi-synchronous replication. It's kind of a hybrid.
Best of both worlds.
Kind of. Typically, you'll configure one follower to be synchronous. This gives you that durability guarantee the data is definitely on at least 2 nodes before the write is confirmed.
Okay, that covers the data loss fear.
Right. And then all the other followers can be asynchronous. They provide the read scalability and don't block the leader if they lag a bit. If your main synchronous follower fails, often you can promote one of the asynchronous ones to become the new synchronous follower, adding resilience.
That makes a lot of sense. You get durability from the one sync follower, but performance isn't totally dragged down, and you still get lead scaling. Okay, let's switch gears slightly. Scaling out reads. What happens when you need to add a totally new follower? You can't just copy the data files, right? The database is still changing.
Definitely not. If you just tried to crep the data files from a live, busy leader, you'd get a mess. Some files would be from one point in time, others from slightly later. The whole thing would be inconsistent. The new follower would basically start up in a corrupted state. Useless.
Right, that wouldn't work. So how do you add a new follower without taking the whole system down and make sure it ends up consistent? Sound like another good interview topic, more on the upside.
Yep. The general process involves a few key steps, all focused on consistency. First, you need a consistent snapshot of the leader's database, like a picture of the data at one specific instant.
Okay, a snapshot. But doesn't taking that lock up the database?
Ideally, no. Most modern databases have ways to take these snapshots without locking everything up. Think of backup mechanisms. They often do this. You want the leader to keep serving requests while you grab this consistent view.
All right, so you get a stable point-in-time snapshot. What next? Ship it over to the new machine.
Exactly. You copy that snapshot data over to the node that will become the new follower. Now, here's the crucial part. That snapshot is already slightly out of date, right?
Right.
Writes have happened on the leader since you took it.
Mm-hmm.
So the new follower needs to connect to the leader and say, okay, I have the data up to this specific point in your history. Give me everything that happened after that.
So the snapshot needs to know exactly when it was taken relative to the leader's change log.
Precisely. The snapshot has to be associated with a specific position in the leader's replication log. Different systems call it different things. PostgreSQL uses a log sequence number, an LSN. MySQL uses bin log coordinates. But the idea is the same, a precise marker in the stream of changes.
Got it. So the follower asks for everything after that marker.
Yep. The leader then streams all the log entries, all the changes that occurred after the snapshot, point over to the new follower. The follower replays these changes, applying them in the exact same order they happened on the leader.
So it's like fast-forwarding history from the snapshot time to the present?
Exactly right. Once the follower has processed that whole backlog of changes and its data perfectly matches the leader's current state, we say it's caught up.
And then it just starts processing new changes as they come in, like any other follower.
Correct. At that point, it's fully synchronized and can start serving read requests and receiving new updates in real time. And the beauty is, the leader could keep running the whole time the snapshot was being taken and the new follower was catching up. Minimal disruption.
It sounds like the core idea is consistent snapshot plus log replay, but the actual commands, the tooling, that probably varies a lot between, say, Postgres and MySQL.
Oh, absolutely. Some systems have really slick automated tools for adding replicas. Others might involve more manual steps, specific SQL commands or configuration file tweaks. But yeah, the underlying principle, consistent snapshot, identify log position, replay changes, that's fundamental. Knowing that process, even at a high level, shows good operational understanding in an interview.
So let's recap. Leader-based replication. Single leader for writes, multiple followers for reads. Gives you consistency at the source, plus read scalability. Key trade-off is sync versus async replication.
Right. Synchronous gives stronger consistency and durability, but hits latency and availability if the sync follower fails.
While async is faster for writes, leader stays available, but there's that small risk of data loss if the leader fails before changes propagate.
And semi-synchronous is that common middle ground. One sync for safety, others async for performance.
And adding new followers needs that consistent snapshot plus replaying the replication log from the snapshot point onwards. This has been super helpful, especially, framing it for those senior interview loops.
Definitely. Being able to discuss not just what it is, but the why and the trade-offs. And that makes a difference.
Okay, so final thought then, something to chew on. We talked about sync, async, semi-sync. Can you think of specific, concrete examples of applications where you'd strongly prefer one over the others? Like, where would you absolutely demand synchronous replication, even if it means slower writes? Maybe online banking.
Yeah, financial transactions are a classic example where losing even one transaction is usually unacceptable. Strong consistency is paramount.
Okay, and where might async be totally fine or even better? Maybe like social media feed updates? If someone misses seeing the absolute latest post for a few seconds, it's probably not the end of the world.
Exactly. Or maybe website analytics tracking. High write volume, but if you occasionally lose a few page view events on a leader failure, it might not critically impact the overall trends you're monitoring. The higher availability and throughput from async might be worth that small risk. Thinking about those specific application requirements and mapping them to the replication trade-offs, that's where the real design thinking comes in.
Perfect. Lots to think about there. That's our deep dive for today. Thanks for joining us.